All right, we're going to practice some proportion work today. And in this, we're not going to do this business, but we're going to use these numbers for our proportional work. So in number one, is the number of Starbucks in the U.S. proportional to the number of Starbucks in North Korea? Now, remember what that means. For two things to be proportional, it simply means that one ratio must equal the other ratio. So if we're looking at the U.S., Starbucks to population. Okay, so that's the U.S. Now let's look at South Korea. How many Starbucks should they have if they are proportional to the United States? So we're playing the what if game basically here. And we could do this a couple of different ways, but I like to solve proportion, so this is what we're going to do. If we solve this proportion and this value of X matches this number of licensed Starbucks, then the answer is yes. So let's try it. We cross multiply, we divide. If South Korea was proportional to the U.S., they should have 1,022 Starbucks. Well, they only have 312. So is the number of Starbucks proportional? The answer to that is no. Because to be proportional, South Korea should have 1,022 Starbucks, but instead they only have 312. Number two. If the United Kingdom wanted to have a number of Starbucks proportional to that of the U.S., would they need to increase or decrease the number of Starbucks in the U.K.? So again, we're comparing the U.S., and now we're comparing to the U.K. So the U.S. is 6,530 compared to their population of 325.7. How many Starbucks should the U.K. have if they have a population of 66.2? So again, the what if game. We're trying to figure out, does this number of Starbucks need to go up or down? So we'll compare that to our value for X. So I cross multiply. I found a value of X of 1,327. This is how many Starbucks they would need to be proportional to that of the United States. Well, they only have 951. So they would need to increase their Starbucks by 376 to get a total of 327 in order to be proportional to the United States. All right, enough of Starbucks. Let's move on to education expenditures. So we're using this lovely piece of information. If the number of school districts in Kentucky were proportional to the number of schools in Michigan, how many school districts would we expect to see in Kentucky? Again, we're playing the what if game. We are comparing Kentucky to Michigan. The big key here is how many would we expect to see in Kentucky? So we're going to put an X here. So this is, oh my gosh, this is the wrong table. Oh no. Because these are expenditures, not school districts. Son of a biscuit. Pause. And unpause. Oh look, school districts. Okay, so we are comparing Kentucky and Michigan, and we're looking at school districts compared to the population. So the key here is how many would we expect to see in Kentucky? So there's the X. So the population of Kentucky is 4.4 million. Then we go to Michigan. They have 548 school districts and they have 9.9 million people. So to solve these, right, we're going to cross multiply, and if Kentucky was proportional to Michigan, they would have roughly 244 school districts compared to the actual that they only have, which is 173. So they would have, 71 more school districts if they were proportional to Michigan. Okay, let's look at number 4. If the number of school districts in Indiana were proportional to the number of school districts in Illinois, how many would we have in Indiana? And then let's compare that. So Indiana compared to Illinois. And the key here is how many would we expect in Indiana? So there's the unknown. So Indiana's got 6.6 million. Illinois has 12.9 million people and 859 school districts. So we cross multiply and we come up with an X value of 439 school districts. Compare that to the actual. Indiana only has 295, so we would need 144 more if we wanted to be proportional to Illinois in the number of school districts. Okay, pardon me while I flip backwards. Okay, so that was a screwed up one. Okay, why does that look weird? at the end of 2012, hold on. All right, so I'm not sure why this video is so jacked, but that's okay. Okay, so at the end of 2012, the federal debt totaled $16.1 trillion. So we're going to calculate the federal debt per capita for 2012 using a population of 314 million. So remember, debt per capita means we're going to put the debt, 16.1 trillion, over the population of 314 million. Well, the easiest way is to change these things into scientific notation. So 16.1 times 10 to the 12th over, timeout, I should write down what I say, 16.1. Then we've got 314 times 10 to the 6th. Oh my goodness. There we go. All right, so now we divide. If we divide these numbers, we get 0.051279, and then we subtract our exponents, times 10, what is my deal? Times 10 to the 6th. Okay, so that 6 tells me to move my decimal 6 places. 1, 2, 3, 4, 5, 6, which gives me roughly $51,273.90. So in 2012, this is the total accumulated federal debt would be roughly over $51,000 per person. Now, if we go to letter B, how does the federal debt per capita compare to the per capita income? Oh my gosh. Well, if you take the debt, right, so this is the debt per capita, and you subtract the per capita income, we have a difference of $8,580.90. That means the federal debt per capita is $8,580.90 more than what the average person takes in. And that's just not okay. You cannot spend nearly $9,000 more than what you take in every year. It's just, that's not going to get it done. It's not going to get it done. Okay, now let's do a little CPI refresher. Use the table to find and write down the annual CPI for 2015. Well, that's right here. So 237.017. And what does that mean? Well, for the particular basket of goods and services used to calculate CPI and to calculate inflation, that basket of goods and services would have cost $237.02, right? We round to the nearest penny, we're talking money. So at that time, that's what it means. So can you find any evidence that there's been a decrease in the value of goods and services, and where? And then here's the thing, there's a lot of spots. I mean, just quick looking, from June, July, and 16, it goes down. From June to July, there it goes. Here it goes down, there it goes down, there it goes down, there it goes down, there it goes down. So there's a lot of spots, right? Those are just the quick ones that I could see, but there's a bunch, right? So there are times when prices actually do go down. I know we don't believe it very much, but it does happen. And the median house of goodness gracious, the median value of houses sold in the state of Indiana in 2011 was approximately $130,000. What was the comparable median house value in 1995? Assuming the housing market followed inflation. That's a big assumption. So we are doing a comparison of 1995 to 2011. And because we are talking about money, that is a CPI calculation. Now, you'll notice that this is not real helpful here, right? We're going to have to go back to our packet and use what we have in your packet. So I don't remember what page that's on, but you're going to want to go back to that. So we know that in 2011, the value of the house was $130,000. If you look at your page of CPI values, you'll notice in 1995, the CPI is 152.4, and in 2011, it's 224,939. And we're trying to figure out what would that comparable price be in 1995. So we cross multiply and divide, and the comparable price would be $88,077.21. Number 9 is similar. We're talking about a house in the suburbs. Again, this doesn't really work. We need the table from our packet. It was worth $77,500 in 1986. We want to compare to August 2017. Oh, shut the front door. We're going to need this table for that one. Okay, so money on the top, CPI on the bottom. So in 1986, let's use red, was $77,500. And in 1986, according to our table in our packet, the CPI is 109.6. We're trying to figure out the cost of August 2017. When you look August 2017, we're at 245,519. We cross multiply and divide, and we get $173,610.61. And there's a comparable price for August 2011.